one of the last concepts of compositions of a function is putting a function inside a function. So that's what we're going to do here. I have some slightly different notation for you. So this here is not multiplication. This here means this is another notation. Notice this is an open circle, and this here means composition. Okay? It's not multiplication. So another way of writing this is saying f at g of x. So we've seen this notation before. So these two things is just notation, and it means the same thing. So this is notation. That means the same thing. Okay? Just as though we have different ways of saying the same thing in English, we have different ways of saying the same thing in math. It's just a preference. However, when I see this form of notation, I always rewrite it this way. It's just easier for me to see. So notice there is no number on the inside. That is key. Because there is no number on the inside, unlike the ones where we did numbers, that means that we are going to start with the outside function. So we're going to start with the outermost function. Okay? And that then would be f. So I'm going to look at my f function, which is right here. So my f function, let me just write this down, is f at x is equal to 3x squared plus 2. But remember, I'm going to be replacing. So here I'm going to be replacing with something. So the way I'm going to write it the next time through is I'm going to write f of something is equal to 3, and wherever I see an x, I'm just going to have what I call a placeholder. So this here, these here are just placeholders. And remember, I could have more x's here, then I would have more parentheses. So what am I replacing my x with? Well, I am replacing my x with the other function, which is g of x. So what is g of x? If we look up here at the top, g of x is 2x. So I'm replacing that with 2x. Notice no math happens over here. This is all notation. This is all just y. It's just in function notation. So that means now I got to clean this up. So I have f of g of x, and that equals, well, I have to do exponents before multiplication. 2x squared is the same as 2x times 2x, which gives me 4x squared plus 2. And then that means, notice it just goes down for the ride. I'm not changing anything on here. And that equals, well, 3 times 4x squared gives me 12x squared, and nothing's happening to the 2. So that there is my final answer for that composition. Okay? But notice I could be asked to do it in the other order. I'm going to write this here. So now we're going to find g of f of x. So remember, the other way of writing this is to write it g of f of x. So I'm going to look for my outermost function first, because I don't have a number in here. So I'm going to start with outermost function. So I'm going to start with the g function. So what was the g function? my g function, g of x, was 2x. I'm going to replace that x. So I'm going to leave a space for it to be replaced. Fix my camera so I get the bottom of my screen. So what am I putting in g of x? In g of x, I'm putting in the function f at x. So g of x was 2 times something. And what was my f at x? My f at x was 3x squared plus 2. Okay? This step is real important. Don't leave that step out or you'll get confused. So then that means that my final answer is g of f at x is equal to, don't forget, that 2 has to distribute to everything inside. So 2 times 3x squared is 6x squared, and 2 times 2 is 4. So for my second type of function, that is my answer. So remember, with these, you start with the outermost function. Don't forget to have a placeholder. Notice in both of these, we had a placeholder, and then we substituted in what was inside the parentheses.